Today's job is to repair a thread on this, I don't know what it is, whether it's a jacking shaft or a feed screw or something, out of a concrete cutting sawing machine of some description, I believe. And it's in basically not too bad condition, the main Acme thread here at least, but there's a small thread here which is properly done in. So we're going to try and repair this, and I've been mulling over the various options for doing this. I don't really want to try and weld it up and recut it. I'm not confident in my welding to do something like this. I don't have a rotator to do it nice and evenly, and I'm a bit concerned about what introducing heat into the thing might do, whether it'll bend it, change the condition of the steel, whatever. Not that I know quite exactly what kind of steel it's made of. I have run a file across here, and where did I do it? Just there. And it doesn't seem to be very tough particularly, so what I'm going to do is I'm going to turn this down and then cut a smaller diameter thread on and make a sleeve threaded on the inside to screw onto the smaller thread that I cut, and then we'll screw that on, Loctite on, and then return that down to the 30mm diameter here and recut a thread on that. Yeah, that's the plan. This is 30mm diameter here, so 30mm by 1.5mm pitch. This part of the shaft is 24mm. So I am thinking that if I take this down to 26 and cut a 26 by 1.5mm pitch thread on that, that will still enable my sleeve to slide over this, and then we'll be using the new thread on here as a kind of thread gauge for the bore of the sleeve, which is going to thread on it. Right, I've got this lead screw, held in the Bernard multi-size collet chuck, and we've got about a foul run out on the part that we're going to be turning. Well, next to the part that we're going to turn. So I'm thinking that's going to be fine, that's not a problem. I like to use a bed stop for setting the length of things that I'm turning, so that's roughly the position at all when we're finishing our cut. So I'm just going to move the bed stop down here. And final adjustment can be done on the compound slide. Well, this is a bit tougher than mild steel, as you'd expect for something like this, which is why I'm using some coolant on it. About 0.6 to go. Go along a bit. Still see the end of the original thread there, so do. Right, just put a little run out groove in there. We're threading up to shoulder, metric thread on an imperial lathe, so we'll be going pretty slow, but I still need to be able to stop this thing pretty rapidly. Yeah, once we start, the lead screw is going to be engaged all the time, so it's going to be a case of stopping, winding out, reversing, winding in, forward again, and so on. I did a web search for how many passes on a 1.5mm pitch thread. Found a Sandvik web page which suggested 6 passes, and actually gave the depth of each pass. Gradually getting less as you get towards the full depth of thread, as you'd expect, so I'm going to give that a go. Right, so these are the depth of cut on each pass that I found on the Sandvik page, and these are actually radial depths. So seeing as the crossfeed dial on this measures diameters, I'm going to have to double all these figures when I go through this, but yeah, let's see how we get on. Right, I'm going to use some neat cutting oil on this rather than the soluble oil, just so it's less messy and I can see what's going on. Well, I added an extra pass at the end there, and I'm going to add a spring passer. I'm going to take another pass at the same setting as the last one. That looks too big. Wow. Just slight witness here, slight run out, and we're just touching on this side. I think that's in as far as we want to go, and actually that doesn't look too bad at all. I would have expected the full form insert that I'm using to have topped the thread a little bit under 25.95. Yeah, that's about it. That's pretty good. Right, I wanted to use something a bit tougher than mild steel for the threaded sleeve that's going on this shaft, and I found a piece of stainless, and it is just a little piece of stainless, probably 303, but I think that would be quite a good choice. But because it's only a short piece, I've had to put the 3-jaw chuck back on the machine because the multi-size collets don't like gripping short pieces. So yeah, got this in the 3-jaw chuck, and it doesn't matter if it runs out a little bit. I'm just gonna drill and bore out the middle. We'll thread it and face the end so that the hole in the end is square, and then that'll be good to screw onto the shaft, and we can do the turning of the OD afterwards. Right, I think that's done. going in there okay. So we'll clean this up, put some Loctite on it, screw it back on afterwards, and come back to it tomorrow and to machine the thing up. That is quite nice. Happy with that. Right, I think that's on there. Right, I've got this lead screw back in the collet chuck. The new sleeve should be well stuck in place. So all I need to do now is turn it down and thread it. Yeah, I think we need some coolant on this. take the end down a bit. It's too long at the moment. Need to take this back to the end of the keyway. I think that will do as far as the length is concerned. Let's just check diameter again. 29.87, so that's certainly down to where it doesn't need any more off of there. I need to put a run out groove here, and then we'll cut the thread again. I might put a little chamfer this end as well, although I can do that with the threading tool. Overshot last time, I've not gone far enough. It's okay. that is done. It won't go right on because it's a nylock nut, but that looks alright. Let's check the other one. The other one should be the same, you'd hope. Yeah, I think that's alright. Actually, I've got a little lump on that. Just
got good eyesight.
Actually, where I didn't stop it quick enough.
You overshot.
Overshot. I just caught the edge. I should just file that off. I think that'll be okay. Right, I'm just gonna give it a quick wire brush to clean this up. And I think that is it. Good as new.
Yeah.